new topic and new outfit, by the way. This is made from recycled space debris, by the way. Not really, but it would be kind of cool. It would be kind of cool, wouldn't it? Now, let's talk about EO applied in the mining industry. Now, what if I told you that the solution to faster, safer, and also more cost-effective mine observation isn't actually on the ground, but up in space?
If the solution to mine surveying lies in space, it sounds like surveyors should start gearing up for zero-gravity training.
Well, no, not necessarily, Elsa, but thank you very much for your unasked input.
Just saying.
Yeah. Don't you have anything else to do currently? I mean, I have to introduce our next guest.
Allow me to take care of this, Chris. Ladies and gentlemen, it is my honor to introduce the president and CEO of PhotoSat, Andrea Krupa.
Let's give it up. Welcome, Andrea.
Thank you very much.
Great to have you.
Thank you very much.
Please have a seat.
Great.
All right. So, how do you like the setup?
It's lovely.
Lovely.
Yeah.
Great.
I'm really enjoying the screens. Yeah.
So, thank you very much for taking your time to be with us. You flew in from Vancouver yesterday?
Yes, Vancouver.
Wow, look at that. So, we're going to start it off. Once again, we're talking about mine observation from space. Maybe you could tell us in a few words what your company actually does. What is PhotoSat's business, and what are your customers?
Yeah, so PhotoSat is a geospatial analytics company. So what we do is we take data coming out of satellites and use machine learning and geophysical processes to create applications for the mining industry. Actually, any resource industry. We focus primarily on mine sites and mining exploration, mine development. So through the figuring out where resources might be, all the way through to building a mine, operating the mine, and then closing the mine.
Wow. You just talked about basically your main focus, the mining sector. What are the main challenges that this industry faces, and what solutions are currently in place?
So I think the biggest challenge right now in the mining industry is actually what we would call its social license to operate. So in mining, what the biggest trend that we've been seeing is that mining companies have started to realize that the behaviors and actions of a single company affect the entire industry. Mm-hmm. So if you have
in a positive or a negative way.
In a positive or a negative way. And unfortunately, more in a negative way than in a positive way. So if you have, we had a major mine failure in Brazil, and it was a huge tragedy. Many, many people died. And that didn't just create a ripple through the mining industry, that created a shock wave through the mining industry that brought in a bunch of new standards, new best practices, new requirements for operating and for monitoring that affect the global mining population. And so from an EO perspective, from an Earth observation perspective, if you have a mine site now in Chile, you might also have a mine site in Argentina and in Namibia and in Australia. And there are very few technologies where you can look apples to apples at those different sites. And space is kind of ideal for that. So it's really interesting in that way.
So those are some solutions that are in place. How can space be added value for the sector? And what technologies are currently being used to answer their needs? Now, you mentioned once again that currently on the ground, if you have these different sites on the ground, it's very, very hard to manage, to oversee, and so forth. So where does space come into play? How does it actually help?
Yeah, so I think space comes into play in the sense that when you're using space-based sensors, you're using the same sensor to, say, for example, you're getting measurements of your tailings facility, and you're using the same sensor to monitor all of your different sites. So if you're sitting in your head office in Brisbane or Perth or Vancouver, and you're looking at all of your different sites globally, and you're wanting to see which ones are operating to standards, which ones are maybe needing a little bit more attention or maybe needing more focus, when you're looking at different data sets and data sources, it's very actually hard to compare that. When you're looking at a data set that comes from the same satellite, being processed the same way with the same specs, now all of a sudden you can have a much more comparable data set. And from the mining industry, what that really does is it allows them to justify themselves and hold each other more accountable. So when you think about the things that we're doing right now with space technology or with satellite-based technology in the mining industry, there's a lot of talk about using INSAR, for example. INSAR is a sensor where people are looking at, are we able to see if things are moving that aren't supposed to be moving, right? Which is you never want things to move. It's not great. Now we're looking at, can we use thermal sensors or hyperspectral sensors to look at where water might be on sites? Water is probably one of the biggest problems in mining. There's either too much water or there's not enough water. So if we're now able to use these space-based sensors, we can look globally at solving some of these problems or answering some of these questions.
Okay, so I think that's pretty well understood. Let's say the general benefit that this technology and up in space has to offer. But then again, I'm thinking of the vast amounts of data.
Yes.
And how to make sense of all that data coming in might be one of the biggest challenges also for the industry, for the people working on the ground in the end. So how exactly did you understand your customers' needs in this regard, and how did you adapt to that?
I think one of the biggest challenges of the space industry is not understanding what the customer needs. So one of the things PhotoSat did is we grew where we were planted. We're actually not I say we're a geospatial analytics shop, and that is what the space industry would classify us as. But really, we're a bunch of geologists, geophysicists, and mining engineers who have been on sites and had these problems, and then said, okay, is there a technology that we can use to solve the problem? So we came at it from a different perspective. I think a lot of the time in the space world, people will put up a satellite with a certain sensor, and it's almost like if we build it, they will come. Right? If we build this sensor, they'll find a problem that it will solve. Whereas for us, we came at it from the opposite way. Everything we've developed has been developed because either one of us or one of our customers has come and said, I have this problem. Can you solve it? And then we go shopping for the sensor rather than the other way around.
Is it also a bit of your personal background before you started the company, PhotoSat, or basically before you joined the company?
So my personal background is more in the psychology world. I did study civil engineering, but then became a psychologist. But my father is actually a geophysicist in oil and gas and mining. And so I grew up talking a lot about rocks as a kid. So,
exciting. So what do you think are areas for improvement you see in providing these services in the sector?
I think the biggest hurdle we have is in the space industry and in the satellite world, we use a lot of jargon, and people do not understand what we're talking about.
True.
So you have mining engineers. One of the things, for example, one of the things we did at PhotoSat is about probably 10 years ago, I banned all the D words from PhotoSat, DEM, DSM, DTM. A mining engineer wants a topographic survey.
Right.
They want cut and fill maps. They want volume data. Like, if I say, oh, do you want that in a DEM or a DSM or a DTM? They have no idea. Right. So I think that's a big hurdle, and I think that's why a lot of companies really struggle with the end user, because they are not speaking the same language. And they're not creating sensors that are solving problems, that are the actual problems that they have, and part of that is because they're not speaking the same language.
Not speaking the same language, probably not only an issue for the mining industry, but also other sectors working with space companies.
Definitely.
Probably, it's probably very universal. So there you see most potential for improvement, or are there other areas?
I mean, I think if we can improve the communication between people that actually have mud on their boots and people who are creating things in space, that will make some of the other improvements. So some of the other challenges that I see, I often get brought into conversations with satellite operators early on now when they're actually road mapping out, this is what we're going to launch, this is when we're going to launch this sensor, this is phase 1. So I get brought into these conversations quite early on to help them determine what the sensors that will actually have use cases are. And that in itself has been a big shift, right? In the past, we never got brought into those conversations. PhotoSat's been around for 30 years. I mean, we signed our first deal, our first partnership with a satellite operator 31 years ago. So we've seen a lot of progression. I wasn't involved the whole time, but we've seen a lot of progression throughout the industry. So, I mean, I think one of the biggest challenges is in mining, for example, water is going to be a huge issue. So we have thermal sensors launching, but it's single band thermal sensors. So if you want to look at water applications, you need multiple bands, right? You need more, so you need more data as a shop like PhotoSat, but the end customer just wants to know, I have a problem or I don't have a problem. So we need to get the right source of information to be able to provide a very simple solution, and that's where there's a big disconnect.
Now, obviously, your main focus currently is on the mining sector. Do you see other applications and developments for PhotoSat in the future?
Oh, absolutely. I mean, I think, like I said, the mining sector was sort of where we knew the most about, right? We grew where we were planted as a company. We heard a little bit from the previous panel. There's a lot of different applications in agriculture. There's a lot of applications in things like flood zone mapping. So there's a huge actually application for flood zone mapping, emergency response. And then when you start to look at some of the applications outside of the Earth, space-based exploration or resource mining, lunar mining, things like that, satellites are really the only way you're going to get most of that information that you're going to need, because we don't have the same ability to fly drones or fly LiDAR, things like that.
Is that actually something you're looking into, like space resources? Is that something you've ever thought about, or you're currently moving in that direction?
Yeah, I think it's one of those things where, as a company, we're pretty geeky, right? Like, that's the whole industry. It's fine. I'm okay with it. And so, if we start talking about, well, let's survey the moon, right? So one of the things that PhotoSat does is PhotoSat can do topographic surveying, so like elevation modeling of the surface of the Earth to 10-centimeter vertical accuracy. So I can tell you something. I can tell you if it's the road or the sidewalk. That sort of, and from space, from satellites. And that's kind of unprecedented in the market. So we're trying to see if we can take that technology and apply it to the data sets of the moon right now, so that we can do a very high accuracy elevation model of the moon. So mapping all of the craters, mapping everything that's going on. And that, it would be great if there's a commercial application for that. I think that's just one of those things that excites us, so we're testing it and we're doing it. But I do see applications for that for any sort of infrastructure development, site planning, location planning, things like that.
Wow, interesting. Are there any questions here from the audience, by the way? Raise your hand, we can get you a mic. No? David, listening?
I gave questions.
Yeah. No, but really, once again, looking ahead and sticking to the topic of space resources. You said you're kind of working on that. Can you give us some more details? What does that mean? Are there companies you're working with already in this field?
No, so we're doing that internally as our own R&D project. So everything PhotoSat does has been internally developed. We have our own R&D team. And so it's something that anytime there's a new sensor or a new data set that comes online, we do some kind of testing with it to see what's the quality of this data, what can we do with it, how can we manage it. So we're doing the same thing with a lot of the lunar data sets. And this is a pretty new thing that we've started to do. And it's really looking at, because right now there are, stereo images, which is where there's 2 images of the same space captured from 2 different angles. And we're sort of looking right now at what can we make with that? What can we find out? If there's more multispectral data or hyperspectral data, can we start looking at
All our mics are off? Can we switch to the hand mic?
Oh.
Try it again?
Okay, am I back? No?
No, you're not back. But we have a backup plan. All right, let's try that.
Okay, there we go. Am I here? All right. So we're looking at things like, can we do alteration mineral mapping of the moon? So can we look at, where the silicas are, where the feldspars are on the moon? And yeah, this is all done right now. It's all done internally as sort of our side of the desk. It's an interesting problem. And really, that's what PhotoSat does well, is we solve, and we want to solve interesting problems that don't have a solution in the way that we're looking for it. So when we look at topographic modeling of mine sites, we're not competing with other satellite companies. We're competing with LiDAR. We're competing with drones. We're competing with other technologies entirely. And so we're trying to apply the same thing to the moon.
And I guess these conferences, these events are ideal, once again, also to maybe, make some new connections. What are the main reasons you attend these events? Like, why did you say yes to this? The personal question.
Yeah, I am a very curious person. And so I said yes to this event out of curiosity to see, okay, well, what is happening, right? Like, I have a personal goal where I would love to be the first company to have a, commercial contract to survey the moon for a resource or development site, right?
That's a clear statement.
That's a personal goal that I have and that my company knows about, and they're a little bit like, oh, okay, how about the Earth? But that's fine. They follow me. And because of that, it's like, oh, this is a really good opportunity to see what's happening, to see what people are actually doing. Because I think when I set this goal, it was years ago, where it was this really kind of futuristic concept, whereas now it actually doesn't seem that far away. Now it seems more attainable. And so I like to continue to be curious about what's happening.
We're definitely happy that you took the time to join us here today. Looking at the time, we run out of time once again, but all good things come to an end when you're having fun. I had a lot of fun.
Thank you.
I hope you did also, ladies and gentlemen. Let's give it up one more time for Andrea Krupa, CEO of PhotoSat. Thank you very much.
Thank you very much.
I'll take that.
Thank you.
And now I'd like to invite everybody to a quick coffee break outside in the foyer. Just be back at 10:55 for our next session. Until then, enjoy the coffee, enjoy the fresh air, but be back on time. Thank you for your attention so far.